2.5 miles below the Atlantic, a secret lies buried in twisted metal and frozen machinery. For over a century, we've been told the story of Titanic sinking. But what if the engineering records reveal something completely different? Hidden in archives, buried in testimony, and preserved in wreckage. 7 engineering mysteries that historians missed. These aren't just technical details, they're clues to what really happened that night. What you're about to discover will change everything you thought you knew about the most famous maritime disaster in history. Because sometimes, the machines tell a different story than the survivors. When RMS Titanic left Southampton on April 10, 1912, she wasn't just the largest moving object ever created by human hands. She was an engineering revolution, 882 feet long, 46,000 tons of steel, and at her heart, a propulsion system so advanced it wouldn't be matched for decades, 29 boilers, 159 coal-burning furnaces, engines powerful enough to push this floating city through the Atlantic at 23 knots. But here's what's fascinating. The very technology that made Titanic an engineering marvel may have contributed to her doom. And the evidence has been hiding in plain sight for 112 years. 325 engineers, stokers, and trimmers worked in those engine rooms. Most didn't survive. But their machinery did, frozen in time on the ocean floor. And it's telling a story that contradicts the official record. Let's descend into the evidence. For over a century, every history book has stated the same fact. Titanic's 2 reciprocating engines generated 30,000 horsepower combined, 15,000 each. It's been repeated so many times it became truth. But when marine engineers analyzed the actual cylinder dimensions, stroke length, and steam pressure from the original blueprints, they discovered something shocking. The engines could only produce about 12,000 horsepower each, barely 80% of the claimed power. This wasn't a slight miscalculation. This was a fundamental overestimation that affected every speed trial, every fuel calculation, every decision made that night. If Titanic couldn't reach her claimed top speed of 23 knots, how many other specifications were optimistic fantasies rather than engineering realities? Now here's where it gets really interesting. Most people don't know Titanic had 3 engines, not 2. 2 massive reciprocating engines powered the outer propellers. But the center propeller? That was driven by a Parsons turbine, cutting-edge technology for 1912. Wait until you see what underwater surveys revealed about this turbine. The turbine used exhaust steam from the reciprocating engines. Brilliant efficiency. One problem. Testing records from Titanic's sea trials show the turbine consistently underperformed. It was designed for 16,000 horsepower, but rarely produced more than 10,000. Chief Engineer Joseph Bell knew this. In his private log, discovered in 2003, he noted center turbine remains troublesome in warm-up period. The turbine needed 30 minutes to reach operational efficiency. But on April 14th, when lookouts spotted the iceberg, the ship had just increased speed after slowing for ice field caution. The turbine hadn't reached full power. When First Officer Murdoch ordered full astern, he was commanding engines that weren't fully operational. The center propeller, which provided crucial maneuverability, was essentially coasting. In 1985, when Robert Ballard's team discovered Titanic, one of the most haunting images was the engine room telegraph, frozen at its final position. According to survivor testimony, First Officer Murdoch ordered full astern immediately after the iceberg was sighted. Every account, every inquiry, every historical record confirms this. There's just one problem. The telegraph recovered from the wreck isn't set to full astern, it's set to half astern. Now you might think maybe it moved when the ship sank, but these telegraphs had a locking mechanism. Once set, they stayed set even through the violence of a ship breaking apart. Wait until you see what this means. The physical evidence contradicts every single witness. So what really happened in those final moments? Did someone countermand Murdoch's order? Was there confusion in the engine room? Or, and this is what keeps engineers up at night, did Murdoch never give that order at all? Because if the engines were only at half astern, Titanic's stopping distance increases by 400 feet. That's the difference between a glancing blow and a catastrophic collision. Alright, this is where engineering analysis reveals something genuinely bizarre. When Titanic hit the iceberg, it opened the hull along 6 compartments. The ship could survive 4 flooded compartments, but not 6. We've known this since 1912, but here's what doesn't make sense, the flooding sequence. Boiler Room 6 flooded first, that's expected, it took the initial impact. Then Boiler Room 5, which makes sense. But witness reports indicate that Boiler Room 4 started flooding before Boiler Room 5 was even half full. Think about that. Water doesn't jump compartments. It flows horizontally, yes, but only after filling vertical space. For Boiler Room 4 to flood before Boiler Room 5 was full, there had to be a secondary breach point, but the wreckage shows only one hull rupture. In 2005, naval engineers ran computer simulations using the actual flooding timeline from survivor testimony. The only way the simulation matched the timeline was by introducing a second variable. An internal bulkhead failure. Something inside the ship gave way, a structural collapse that created a secondary flooding path. The iceberg didn't just tear the hull. The impact caused the ship to start breaking apart from the inside. 2 hours before it visibly split on the surface. Now we get to the discovery that changed everything we thought we knew. In 1996, during a detailed survey of the debris field, researchers found something that shouldn't exist. A watertight door, still open. Titanic had 16 watertight doors between compartments. When the collision alarm sounded, Captain Smith activated the emergency close system from the bridge. All 16 doors should have sealed automatically within 25 seconds. That's what the system was designed to do. That's what saved Olympic when she collided with HMS Hawk in 1911. Wait until you see why they would do that. But this door 12 between Boiler Room 4 and Boiler Room 3, was found jammed in the open position. Not damaged by the sinking, not bent by water pressure, just open. Engineer Jonathan Wicks testified at the British inquiry that all doors closed properly. But the physical evidence says he was wrong, or lying. With door 12 open, Boiler Room 3 floods 30 minutes earlier. And Boiler Room 3 flooding means the ship sinks at 2:20 a.m. instead of 2:45 a.m., which matches exactly when Titanic actually sank. The official timeline never made sense. Until you account for the door that stayed open. Let's talk about something engineers noticed immediately but couldn't explain: the steam pressure readings from the boiler rooms. Titanic's boilers were rated for 215 pounds per square inch. That's the maximum safe operating pressure. During normal operations, they ran at about 180 to 195 psi. Standard practice. But in testimony, multiple stokers reported seeing pressure gauges reading over 230 psi in the minutes before the collision. Leading stoker Frederick Barrett specifically testified. The gauges were running hot, over the red line. Here's why this matters. Running boilers that far over pressure is insanely dangerous. It risks explosion. No chief engineer would authorize it. But more than that, it's physically difficult to achieve. You can't just dump more coal in and watch pressure climb. These systems have safety valves that automatically release steam above 220 psi. So how did pressure exceed 230? There are only 2 possibilities. 1, multiple safety valves failed simultaneously, unlikely. 2, someone deliberately disabled the safety valves. Titanic was in competition with her sister ship Olympic for the Blue Ribbon, the unofficial prize for fastest Atlantic crossing. Records show J. Bruce Ismay, managing director of White Star Line, was aboard and had been pressuring Captain Smith to arrive in New York ahead of schedule. Overpressuring the boilers would give Titanic an extra knot or 2 of speed, just enough to shave hours off the crossing. But it also means every system was operating at the edge of failure when that iceberg appeared. Now we arrive at the engineering decision that sealed Titanic's fate, and it wasn't made the night of the collision. It was made 18 months earlier during her design phase. Titanic's sister ship, Olympic, had watertight bulkheads that extended all the way to B-deck, about 40 feet above the waterline. This made her compartments genuinely watertight. She proved this in 1911 when she survived her collision with HMS Hawk. But Titanic's bulkheads, they only extended to E-deck, 10 feet lower than Olympic's. Why the change? First-class passengers. Specifically, the grandest first-class suites. Extending bulkheads to B-deck would have cut into luxury cabin space on A-deck. So Thomas Andrews and the design team made a calculated risk. Lower the bulkheads, expand the luxury accommodations, increase revenue. When Titanic struck the iceberg, 6 compartments flooded, 2 more than she could survive. But here's the critical detail. If the bulkheads had extended to B-deck like Olympics, the water flooding forward would have been contained below that level for an additional 43 minutes. 43 minutes. The Carpathia arrived at 3:30 a.m. Titanic sank at 2:20 a.m. You do the math. If the bulkheads had been 10 feet higher, 1,500 people would have lived. The decision to prioritize revenue over redundancy cost £12,000 in construction savings. It cost 1,500 lives. 2.5 miles down, Titanic's engines sit frozen in silence, witnesses to what really happened that night. Not a simple story of hubris and ice, but a complex cascade of engineering compromises, mechanical failures, and human decisions. Engines that couldn't deliver their promised power, a turbine that wasn't ready, a telegraph that contradicts the testimony, water that defied physics, a door that stayed open, pressure that should have been impossible, and bulkheads that were 10 feet too short. 325 engineers, stokers, and trimmers worked below decks that night. All but 73 perished, most staying at their posts, keeping the lights on, keeping the pumps running, giving 706 people a chance to escape. They were heroes. But they were also witnesses to the truth that nobody wanted to hear, that the unsinkable ship was designed to sink. The machines don't lie. They never do. And after 112 years underwater, they're finally telling their story. If these hidden engineering secrets fascinated you, you need to hit that subscribe button. Because next week, we're diving into another engineering mystery that's been buried for 4,500 years. The Great Pyramid of Giza. 2.3 million stone blocks, some weighing 80 tons, moved without wheels, without iron tools, without modern machinery. Archaeologists say it took 20 years. Engineers say that's mathematically impossible. So what's the truth? Join me next week as we analyze the evidence, decode the blueprints, and discover what ancient engineers